Hello everyone. In this video, we're going to talk about examples from Chapter 4. My name is Fred Rispoli and I'm coming to you from Stony Brook University. So in particular, we're going to look at an example involving what I call a general PDF. We're going to look at the uniform distribution, the exponential distribution, and a couple of examples on the normal distribution. So these examples are based on frequently asked questions and some issues that come up during tests as well. For our first example, suppose we have a CDF, right? The cumulative distribution function is given here. You could see it's defined as a piecewise function. So when x is less than 2, our f of x is 0. When x is between 2 and 4, we get x minus 2 over 2. And when x is greater than 1, we have 1. So this is the cumulative distribution function. Now suppose we wanted to find the PDF, our probability density function. Okay, you must remember here in Chapter 4, we're talking about continuous distributions. So here our PDF is the probability density function. Okay. Well, we will find that, and we have a few other parts to this. We'll find the probability x is between 2/3 and 3. The probability x is greater than 3.5, and then the 60th percentile. So to find the PDF, we need to take the derivative of our CDF. Okay, so if we go back a little bit here, you can see the derivative of constants are zeros. So we get the derivative of these two are 0. And the derivative of this piece here is simply 1/2, which is valid for x between 2 and 4. And so we get our PDF, also defined as a piecewise. F of x is equal to 1/2 when x is between 2 and 4 and 0 otherwise. To find the probability that our random variable x is between 2/3 and 3, now we have two choices. One would be to set up an integral where x is going from 2/3 to 3 and then integrate this. On the other hand, we could just take advantage of the fact that we have a CDF. So we look at f of 3 minus f of 2/3. F of 3, you could see, if we substitute into here, f of 3 will be 1/2. So that's where we get this. And f of 2/3 is 0. So we get the probability very quickly using the CDF. The answer is 1/2. If I wanted the probability that x is greater than 3.5, the first idea we use here is to sort of convert this into the complement, find the probability x is less than or equal to 3.5, and then we subtract that from 1. So we will get 1 minus 3/4, right? This 3/4 we would get by putting in 3.5 here. So 3.5 minus 2, then divided by 2, gives us this value here, 3/4. So we get 1 minus 3/4, which is 1/4. Now to find the 60th percentile, okay, the general rule is if we want a certain percentile, such as the 60th, we express that as a decimal and set it equal to the CDF and then solve for x. So here we get 0.6 is equal to x minus 2 over 2. Okay, so we could try to multiply through by 2, and then this becomes x minus 2 is equal to 1.2. Solve for x, and we get x is equal to 3.2. So that would represent the 60th percentile. Okay, so there's an example just involving a CDF and a PDF. For our next example, we're going to look at the uniform distribution, but first a quick review. If x is uniformly distributed between a and b, then the PDF for x is given by f of x is equal to 1 over b minus a when x is between a and b, and it's equal to 0 otherwise. Okay, so I like to think of this as f of x is equal to 1 over the length of the interval. And if we were to graph this function, okay, we would just get a horizontal line, okay, whose height is b minus a, and this would be good for x between a and b. So you could almost think of this as a rectangle, okay? And I strongly encourage you to think in terms of shapes and geometry when studying continuous probability, because that certainly helps you to do a few things, and here you can visualize. So it's always nice to visualize whenever that gives you a good picture of what's going on. So as an example, suppose we know that the wait time for service at a local DMV, that's Department of Motor Vehicles, is a uniformly distributed random variable, x, from 1 minute to 9 minutes. Okay. And let's say we'd like to find the PDF for x, find the probability that a randomly selected person waits between 1.5 and 5 minutes, find the expected wait time, and the standard deviation of the wait time. Okay, so our PDF is 1 over b minus a, right? Remember, we just looked at that. So b minus a would be an eighth. So we get f of x is 1/8 for x between 1 and 9 and 0 otherwise. Our graph of this would look something like this. The height of this would be 1/8, and this would be valid for x equal to 1 here and x equal to 9 here. So here is a graph of our PDF. Now to find the probability that a person waits between 1.5 and 5 minutes, we could set up our integral, integrate from 3/2 to 5 f of x. So the integral looks like this. When we integrate 1/8 with respect to x, we get x over 8 from 5, well, from 3/2 to 5. So you can see that our fractions would look like this, and our final answer would be 7 over 16. Now, to find the expected wait time, okay, in general, we find that by evaluating an integral from minus infinity to infinity of x times f of x dx. But sometimes we get simplified formulas, okay? And with the uniform distribution, we get a formula which tells us that the expectation of x is a plus b over 2. So that simplifies things quite a bit. We'll get 1 plus 9, which is 10 over 2, or 5. And part D here is to find the variance of x. So again, there are certain formulas that we could use to find the variance of x for the general case. But when we have a uniform distribution, you'll see that in Chapter 4, this formula gets derived. The variance is b minus a squared over 12. So we could substitute in 9 for b and 1 for a. We get 8 squared over 12, 64 over 12. We could simplify that. We get 16 over 3. And then the standard deviation is the square root of this. So our standard deviation here ends up being 2.3. Okay, at this point I suggest that you stop the video and suppose that in the above example we want the probability that the wait time is more than 3 minutes. So you could do this a couple of ways, but I'm going to suggest that you set up the integral and then determine the probability. Okay, did you get an answer of 0.75 or 3/4? The integral would look like this. It'd be an integral from 3 to 9 of 1/8 dx. So we would get 1/8 times 9 minus 3, or 1/8 times 6. 6 over 8 simplifies to 0.75. All right, now let's talk about the exponential PDF. If x is a random variable that follows an exponential distribution with parameter lambda, then its PDF is given by this function here. F of x is equal to 1 over lambda times e to the minus x over lambda for x positive and 0 otherwise. Okay. And lambda is found by calculating the mean for x. So we have this nice continuous distribution with just this one parameter, lambda. The exponential distribution is often used to study probabilities of lifetimes. It's used to study other things as well, but that's sort of a common model for studying lifetimes. And you're probably familiar with a graph of the exponential distribution. It looks something like this. So you could think in terms of an exponential decay here, and here this is the mean lambda. All right, so here's an example. Suppose in a certain crime-infested neighborhood, the time x that a dwelling is burglarized is approximately exponentially distributed with a mean of 2 years. So we'd like to begin by constructing a PDF for x. Then in part B, we ask if you move into an apartment in this neighborhood and intend to live there for 5 years, what's the probability your apartment will not be burglarized during this time? So let's calculate the probability and round off the answer to 4 decimal places. And in part C, we ask, what's the probability that your apartment will be burglarized within a month after you move in? Again, we round off to 4 decimal places. So we know that we have an average of 2, therefore our lambda is 2, and our PDF looks like 1/2 times e to the minus x over 2 when x is greater than or equal to 0, and it's 0 otherwise. So in part B, we're interested in finding the probability x is greater than 5. So we can set up this integral from 5 to infinity of 1/2 e to the minus x over 2 dx. So we could integrate that out and simplify, and then this would give us minus e to the minus x over 2. Okay, we're integrating here. We're going from 5 to infinity. So we can see when we have infinity, our term goes to 0. And so we're left with 5. And due to a couple of negatives canceling out, we end up with e to the minus 5/2. And we could express that as a decimal rounded off. we get 0.0821. In part C, we asked, what's the probability of getting burglarized within the first month? So we could express that as the probability x is less than 1/12. Find this integral using the PDF. So I go from 0 to 1/12, 1/2 e to the minus x over 2 dx. Integrate this out, and we end up with 1 minus e to the minus 1 over 24. So we could calculate that, get our answer as a decimal. We end up with 0.0408. All right, and now we come to our last distribution for this video, the normal distribution. So the normal distribution is one of the most important and well-known distributions. Here we're going to take a look at two examples. In the first, suppose the number of gallons of Gatorade consumed by a football team during a game follows a normal distribution with mean 20 and standard deviation 3. If a game is selected at random, we'd like to find the probability that the number of gallons consumed will be greater than 23. And also, if a game is selected at random, find the probability the number of gallons consumed is between 22 and 25. And then in part C, find the 95th percentile. So as we go through this, I'm going to show you how to make calculations and use the table as well. Okay, it's important to understand that the normal distribution is continuous. There is a PDF, which I didn't even display here. It's a little complicated, but it's not too bad. But the idea here is to find probabilities using the normal distribution table. Okay, so the first step, okay, is we'd like to find the probability x is greater than 23, but we're going to convert that to a z-score. So we calculate z. Let's say z is 23 minus 20 over 3, right? This is your x minus your mean over a standard deviation. We see this works out to be exactly 1, or 1.0. So the probability x is greater than 23. We notice that's a greater than, so we look at the complement. 1 minus the probability x is less than or equal to 23. Express this in terms of our z value. 1 minus the probability z is less than or equal to 1. And that's going to be 1 minus, now we'll use this notation, phi of 1. Okay, so whenever you see a phi of 1 in this section here, or in this chapter, you should think in terms of our table. So what we have to do is use a z value of 1 and figure out the corresponding probability. So let's go to our table. I have a copy of it right here. Now there's two versions or two different pages. Notice with one page we have positive z values down here. That's the one we have to use. But in a other page here we have negative z values. Okay, so when our z value is negative we use this one. When it's positive we use this one. Okay, so we wanted to find the probability z is less than 1.0. Okay, so the way to use this table is we find our z to 2 decimal places, and then you find the row when you just consider the z value to 1 decimal place. So here we have 1.0, but we really have 1.00, so we know we are in the first column. If we had 1.02, for example, then I would use this value. Okay, but the one we want is right here in this red circle. So 0.8413 is what we get over here. But we have to remember that our probability is 1 minus 0.8413. So we end up with 0.1587 as a final answer. Okay, in the part B here, we're interested in the probability the number of gallons consumed will be between 22 and 25 gallons. So I'd like to find the probability. X is between 22 and 25. So now we need to convert both of these values to z-scores. So we can do this either inside the parentheses or outside. I like to do it outside when students are first learning this. So when we convert, remember we take our value. This is an x minus mu over the standard deviation. So I would have 22 minus our mean, which is 20 over 3. So that's 0.67. And then we have 25 minus 20 over 3, 1.67. So the probability we want is equal to the probability z is between 0.67 and 1.67. Okay. When we think in terms of using our table, we're going to look up 1.67 or phi of 1.67 minus phi of 0.67. You can see the values here, but let's take a look at the table. I've noted here, I've tried to identify these using blue circles. So let's look up 1.67. Okay, so first of all, 1.67, that's a positive z value, so I'll be on this one. Here's my 1.6, and then I move over until I see a column labeled 0.07. So you could see 1.67 has a probability of 0.9525. Okay, so that's where we get this number. And then we have to subtract from that phi of 0.7. So phi of 0.7, let's see, let's just clarify that. I take that back. We have to subtract phi of 0.67. So phi of 0.67 would be right here, the 0.7486. Okay, so we work out the subtraction. We get a final answer of 0.2039. Now in part C, we want to find the 95th percentile. So similar to what we had discussed earlier in this video, we start out by thinking in terms of setting a cumulative distribution equal to 0.95. Okay, so what I have to do here is I think of this as a reverse or an inverse problem. Here we have the probability, okay, and we sort of need to work backwards, okay. So I need to use the normal table to figure out what z value is going to give me 0.95, okay. So let's check that out. If we go to the z value, okay, where am I going to get 0.95? So the idea is we look inside the body of the table and we try to get as close to 0.95 as possible. And you see over here I have 0.9495 and I have 0.9505. So sometimes people would take 1.645 because it's right in the middle. 1.64 gives us this value, and this would be 1.65. So you can see over here I have z's 1.645. So now the idea here is we're trying to find an x value. So if I use my formula for z-scores, I know it would be x minus the mean over the standard deviation. So x minus 20 over 3. We could solve this for x, and then we get 24.935, and this would be in gallons. So this gives us the 95th percentile. So 95% of the time, the team will drink less than this amount, and 5% of the time they'll drink more than that amount. Okay, let me have you try another exercise. Suppose in the above example, we want the probability that the number of gallons consumed will be less than 19 gallons. Okay, find the probability. We want to approach it the same way. We want to calculate a z-value and then use the probability tables. And I'll give you a hint. For this example, you must use the normal table with the negative z-values. Okay, did you get 0.3707? Let's see how we could come up with this answer. As a first step here, I calculated the z-value. Now it's 19 minus 20 over 3. And so this will give us negative 1/3. But we want that expressed in terms of a decimal rounded to 2 decimal places, so we could use our table. So we could say that the probability x is less than 19 is equal to the probability z is less than minus 0.33, phi of minus 0.33. So we go to our table, and we need now the one with the negative z values. So minus 0.3, so I know it's this row, and I have minus 0.33, so this gives me the second decimal place. So you could see over here, we end up with 0.3707 to be our final answer. Okay, one last problem on this video. Again, this involves the normal distribution. So suppose the mean and the standard deviation of SAT math exam scores are 513 and 120 respectively in 2014. So again, we have mean 513, standard deviation 120. The scores are normally distributed. So let's say we're asked to find the 30th percentile, part A. Part B, if the score is 700, what percentage of students got higher scores than you in 2014? And C, what percentage of students got SAT math scores from 400 to 600? Okay, so again, we have the 30th percentile. So we have to use our table sort of in reverse, and that should give us a z-value of minus 0.52. Let's check that out. Okay, so I'm looking for 0.30. I want to get as close to that as I can in my table. Okay, so think of this like an inverse function. We want the 30th percentile. So I like to think of this as doing the problem backwards. We have the probabilities, 0.30, okay? What we really need is the x value. So here you can see we get as close as we can to 0.30. So let's go with this value here. the corresponding z value is minus 0.52. So that will be our z. So I get minus 0.52. All right, so if we use this equation now and substitute in everything we know, and remember we're looking for x, so I get 513, that's my mean or mu, plus 120, the standard deviation, times the z that we looked up. Work this out, we get 450.6. So we could round off, and then we could conclude by saying the 30th percentile is approximately 451. Okay, in part B, we suppose your score is 700, and we ask what percentage of students got higher scores than you in 2004. So we want the probability x is less than 700. Okay, at least we want that probability to begin with. We know if we have that, it's easy to get the complement. So we convert 700 to a z-score. We have 700 minus 513 over 120. That will give us 1.56. So now we have to go to the table. Notice this value of z is positive. So we need the part of the table where I have positive z values. Okay. Let's see. We want 1.56. We said over here 1.56. So we look over here. 1.56 is right here. The circle moved a little bit, but you could still see it's close to where we need it to be. We get 0.9406 as an answer. Okay, so 0.9406. So this tells us that 94% of the students got scores lower than 700. So 6% get scores higher than 700. Okay, finally, in part C, we want the probability that a score is between 400 and 600. So our first step, we convert these x values to z values. It's x minus mu over sigma. So 400 minus 513 over 120. So this works out to be minus 0.94. And then 600 minus 513 over 120. That works out to be 0.725. So we'll look up 0.725 first. We go to the table. Now I want the table with positive z values. 0.725. Let's see. So over here I'm seeing 0.72. Okay, so you can see I have 0.7642. Okay, so you can see here 0.7658. Now this was obtained using some sort of technology, and so you can see this is close to what we have. But if you go to 0.725, then you get 0.7658. And then this value here, we have minus 0.94. So here we need to go to the z table with negative values. So minus 0.94 would be right over here. And you can see we get 0.1736. 0.1736. So we subtract these two, and we end up with 59.22%. That would be, you could think of it two ways, the probability a person scores between 400 and 600, or the percentage of people that have a score between 400 and 600. Okay, So we've reached the end of the video. Thank you for watching.